As we know, in last class, you all studied that the what is the transformation of energy and as well as the examples of transformation of energy. Almost, I think, 12 types of energies transformation I have given. So that is what you need to remember that. So what do you mean by transformation of energy? Anybody? Anybody can say what do you mean by transformation of energy, please? So means in a sense,
The change of one
yes.
form of energy into another form.
Very good. So the change of one form of energy into another form of energy is known as transformation of energy. For example, as I told you in last class, so if you're taking a freely falling body, which energy is converting into which energy, guys? A freely falling body, which energy is
Potential
converting
into
into
Potential
kinetic
energy
energy.
into kinetic energy.
energy is converting into kinetic energy. So that is what. Now, if you notice it, today's class we are going to study law of conservation of energy. What is our concept we are going to study now? Law of conservation of energy, and we have to prove with the example. So now, what do you mean by law of conservation of energy means? Please, all of you keep heading. Law of conservation of energy. Okay, so now let us understand first of all, what do you mean by law of conservation of energy? Later we will study with the example. So let's start everyone. Shruti, Shakti. So now if we take here, as we know, energy can be transferred or changed from one form to another. So what do you mean by law of conservation of energy? That is the what we studied in the last class. So according to the law of conservation of energy, whenever energy changes from one form to another, the total amount of energy remains constant. That is only called as law of conservation of energy. So please, all of you write it. What is that? Whenever energy changes from whenever energy changes from whenever energy changes from one form to another. Can you able to write Jayvarsini? One form to another, energy changes from one form to another, comma, the total amount of energy remains constant. The total amount of energy remains constant. The total amount of energy remains constant. That is only what we used to call Ra. What we used to call, guys? Law of conservation of energy. Or else you can see, simply I can say, what do you mean by law of conservation of energy means energy neither be created nor be destroyed. That's all. You can write this is also. Neither be created nor be, what it is, guys? Nor be destroyed. So only it is allowed to transform from one form to another form. Understand, Mahalakshmi? That is only called as law of conservation of energy. Energy neither be created nor be destroyed, but it is possible to transform water. It is possible to transform one form to another form. That is what we used to call as law of conservation of energy. But if you notice it, guys, whenever the energy transformation is taking place, means during the conversion of energy from one form to another, some energy may be wasted. Is it yes or no, guys? Will you accept it, Jayvarsini, Laksha, Manya and Samya, everybody?
Yes,
So during the conversion, some energy may be wasted. During conversion from one form to another form, some wastage of energy will be there. So what is the example? Can anybody say some wastage of energy will be there? What is that? For example, let me take, how many of you know electric bulb? You people know or not? Yes or no? So what is the use of electric bulb? We will convert electrical energy into light energy. Is it yes or no, guys? Please respond. What is our main aim? So we want to convert electrical energy into light energy. So now here some amount of energy will be converting into light and some amount of energy is wasted in the form of somehow. What is that? Anybody can say? Anybody? Aslita, Alana? Anybody can say?
Heat,
Where
sir.
that is what?
Heat energy, sir.
If you touch any kind of bulb, after it is glowing for 1 hour or even 10 minutes, if you notice it, so the surface of the bulb will become very hot. Is it yes or no, guys? Tamil Selvan?
Yes, sir.
No. So that is what, because so this is it that the heat energy is needed for us? It's not
No,
needed.
sir.
So it's not needed. That is why this heat energy here is called as a wasted energy. Understanding? So energy is wasted. For example, you can see you have a fan in our home. Do you have a fan in our home, everybody? So everyone is having fan. So you might be noticing. So if you take the fan, so what is the use of fan, guys? We are converting electrical energy into which energy? We are converting electrical energy into mechanical energy. Yes or no? So now during this, if you'll notice it, so have you touched it? Usually the fan used to make us to rotate and will give you the blowing the air. So what is the use of here? Converting electrical energy into which energy, guys? Electrical energy into mechanical.
Mechanical energy.
But here, some form, it is again some amount of energy is wasting. What is that energy? Anybody? Adarshan, Aswita, please speak. Try to communicate. Then only your skills will improve. That is what I will suggest always. Don't be dumb fellows always. Don't be like a dumb fellow. Now you can see. Now today only, or else now you can see from the night, full night, your fan is rotating. If it is possible to touch your fan, now off the fan and touch at the bottom surface at this one where you are finding the motor and all. So it will be appears like a very hot. Have you noticed it anytime? It will be very here. Have you checked it?
Yes, sir.
Why it is? Because of continuously rotating, continuously the machines are running inside, so that it will lead to the friction. So because of that friction, some amount of electrical energy is converting into heat energy. So here also loss of heat, understanding. So it is also what? One form of wastage of energy. But if you notice it, guys, although some energy may be wasted during conversion, but the total energy of the system remains the same. Do you understand what I'm saying? For example, if we'll take electrical, the total electrical energy consumed, do you understand? Which is equals to the total mechanical energy, means whatever the energy consumed, converted, plus the total heat if we'll add, remains the total energy is what, guys? Remains the total energy is conserved. Maybe it is unwanted form. So we should not say it is wasted energy, unwanted form. For example, in this case, what is happening? Total electrical energy, which is equals to what? The sum of light energy plus sum of heat energy.
Heat energy.
So that is what we used to call as law of conservation of energy. So even though the energy may be wasted, but the total energy of the system remains constant. Understand, Elamukel? Pradosh? Maitreya? That is only we used to call as law of conservation of energy. So please, all of you write it. So write, during energy conversion, some amount of energy may be wasted. Some amount of energy might be wasted. Some amount of energy might be wasted.
Sir, during energy?
During energy conversion, some amount of energy may be wasted. During energy conversion, some amount of energy may be wasted. During energy conversion, some amount of energy may be wasted. Shruti, are you writing? Yes, Tarun? What about Laksha? Laksha is not feeling well, I think. That's fine. So that is what? During energy conversion, some amount of energy may be wasted, but the total energy of the system, but the total energy of the system remains the same. remains the same. It remains the same. Now, let us take one example to understand this law of conservation of energy more clearly. Now, for example, how many of you know crane, guys? Do all people know the crane? Yes, please respond. What is the use of crane?
Sir.
What is the use of crane, Mukesh?
Sir, lifting cars.
For lifting the heavy loads and as well as carrying anything like during construction and all, for lifting anything from the ground floor to second floor or third floor, whatever it is. That is what the importance of crane. Is it yes or no, guys?
Yes, sir.
So now, for example, I will show you the one picture. So all of you notice it and tell me what you are feeling it and what you are getting that. That is what the example we can see. Can you able to see this picture? Everybody, please respond. Yes. So now you might be noticing here what is happening, Ra? What is happening here? You please respond. What is happening here? So they are taking a one ball. You don't think that these many balls are there. This is what the video picture, like multiple pictures is merged here. That is what you are not noticing properly. So now here what they are showing, Ra? Anybody can say? They are lifting the one load or one big stone and they are carrying in with the help of crane. Now, at this height, it is having what energy, guys? Only it will possess which energy? Anybody can tell me?
Potential energy.
Potential energy. Very good. Now, at this place, potential energy is maximum. And as we know, kinetic energy will become what, guys? Kinetic energy will become
Zero.
0 meter per, 0 joules.
0 joules.
Yes, 0 joules. So now if you notice it, now when the ball is released, you can see when the ball is released, so you might be noticing here, it is reaches to the first position. This is what the first position, and this is what the second position, and this is what the third position, and this is what the fourth position, this is what fifth position, like that keep on coming before touching the ground. Before touching the ground, who will be the maximum? Kinetic energy will be maximum, and by this time before touching the ground, potential will become what? 0 joules.
0 joules.
Now,
0 joule.
what I'm saying in the law of conservation of energy, energy remains constant. Yes or no, guys? Remains constant. That is what it is called as law of conservation of energy. Will you accept it? Alana, that is. Now you tell me when the ball is moving to the first position to second position to third to fourth. Now, for example, imagine, let me take this fourth and fifth is a little bit more space. Now you can take at the fourth position, is it the body is having potential energy or not? That is what my case.
Yes, sir.
Yes or no? Yes, but still at the fourth position, some amount of energy is converting into another energy. What is that energy? Also, it is
Kinetic energy.
energy also. That is what. Do you understand? So when the ball is freely falling from here to here, understanding, at every stage, some potential energy is converting into what, guys? Some potential energy is converting into kinetic energy. Potential energy is converting into kinetic energy, and when the same thing, if you throw the ball upwards like this, then by this time what is happening? Kinetic energy is converting into what?
Potential energy.
So like this, always energy transformation will take place. But what is law of conservation of energy? If you do the sum here, total energy, potential energy plus kinetic energy, which is equals to what? Remains constant. Understanding? If we'll do the sum at the fourth position, here also if we'll do potential energy plus kinetic energy, which is equals to what? Remains, it is constant. We'll do at the before touching the ground, remains if we'll do potential energy plus kinetic energy sum, which is equals to what, guys? Remains, it is constant. This is only ways to called as what? Ways to called as law of conservation of energy. Now we will prove with the example with the values also. So let us take, all of you keep heading, conservation of energy during the free fall of a body. All of you keep it. During the free fall of a body. Conservation of energy during the free fall of a body. Shall I start? Everyone? Jayvarshini? Now you tell me. Let me take the three cases. Is it okay, guys? Convenient, Tamil Selvan? Darun, so let me take the three cases. Now you tell me, at the every case, in the body is having a potential energy and as well as kinetic energy. It may be a zero or maximum, doesn't matter. So understand. So now you tell me, when it is freely falling, what is the potential energy, guys? Potential energy formula, which is equals to what? M into G into H. Understand? When it is freely falling, the potential energy possessed by a body is mgh. Same way, what is the kinetic energy, guys? Kinetic energy formula is what?
Half mv square.
Half into m into v square.
Now, what is law of conservation of? Understand, conservation of energy means you can see. So now you tell me, when the ball falls from its certain height above from the ground, then who is decreases? Who is increases? Who is decreases? Who is increases? So as we know,
Kinetic energy
The
increases.
potential energy decreases, kinetic energy increases.
Kinetic energy increases.
energies keep on increases. Girls, will you accept it? Yes or no? Maitreyan,
Yes, sir.
Tamil Selvan, others, Sakti, that is. So when the ball is freely falling, if you notice it, what is happening? Potential energies keep on decreasing and kinetic energies, what is, guys? Keep on increases. Understand? That is what it is used to observe. So now if you notice it, guys, here, so a ball falls more and more and more, its potential energies more gradually it is converting into which energy, Ramonesh? If it is falling more and more faster, then more potential energy is converting into which energy? Which is converting into kinetic
Kinetic
energy.
energy.
Understanding now? But sum of potential energy and kinetic energy of the ball remains same at every point during free fall. Do you understand it? So at this point, if we'll calculate the sum of potential plus kinetic, which is constant. If you at this position, if you calculate sum of potential plus kinetic remains constant. At this position, if you calculate potential plus kinetic remains constant. That is only we is to call as what we is to call, guys? What we is to call? Law of conservation of energy. Let us take with a beautiful example. Let me take just before hitting the ground. Totally, we are having 5 cases. Let me take. So the 5 cases you might be know. Let me assume with alphabets A, B, C, D, E. Is it okay, guys? Everybody, ball at rest and it is started falling. Shall we start now? Energy conservation. Yes or no? So now let me consider when the ball is at certain position above from the ground. This image, you can notice it, you can understand. The ball is at certain position above from the ground. That position is what we used to call Ra. That position only we used to call as at rest. Is it okay, guys? Top from the ground. Is it okay, everyone? Yes?
Sir.
Yes, sir.
Now, at this case, what is the potential energy of the ball, guys? What is the potential energy of the ball?
20 joules.
20 joules. So as we know, at this case, the potential energy means in the sense of PE, which is equals to mgh, which is equals to what? 20 joules.
20
And
joules.
at this case, what is the kinetic energy at point A?
Zero
And the
joules.
point
0
A is
joules.
what? 0 joules. Now both if you sum, which is equals to what is coming? What is the total
20
energy?
joules.
Joules.
Total energy is 20 joules. Is it okay, guys? Please respond, everybody. Now,
Yes, sir.
ball is reaches to which point to which point? Ball is reaches from
A to B.
A to B. Now, when the ball is reaches to the A to B, now some amount of potential energy is converting into which energy, guys? Some amount of potential
Kinetic energy.
into kinetic energy. Have you noticed it? When we are keep on going down, potential energy is decreasing, and who is increasing now? Kinetic
Kinetic
energy
energy.
keep on increasing. Understand, girls? Aswita?
Yes, sir.
Now potential energy become how much at second point? Second point, potential energy is become how much? 50 joules.
50 joules.
Understand?
15 joules.
Kinetic energy becomes how much? Kinetic energy
5
becomes
joules.
5 joules. But if you do the sum at this point, then total energy is how much, guys? Remains
20 joules.
Understand? So remains constant. Next, ball is reaches to the falling point C. That is what? Mid of the journey, almost half. Then what is the potential energy, guys, by that time? Potential energy is 10
10
joules.
joules.
And kinetic energy is how much? Kinetic energy is
10
also
joules.
10 joules. Understand, Jayvarshini? Mahalakshmi? Now if you sum of these two energies remains what? remains 20 joules.
Constant.
Now the ball is reaches to the point D. Ball is reaches to the point D. Now potential energy is what, guys? 5
5
joules.
joules.
And by this time, most of the energy is converting into kinetic energy. That is what? 15 joules. And 5 plus 15, if we add, how much it is coming, Pradosh?
20 joules.
20 joules only. Now, just before touching the ground, because after touching the ground, what is the energy, guys? After touching, what is happening? After touching,
Rest.
the energy will become what? It is absorbed by the ground, so that it will become 0. After touching, total energy will become, total is equals to what? 0. That is why always will take before hitting the ground or before touching the ground. So now before touching the ground, potential energy is what, guys? 0.
0 joules.
Kinetic energy is 20 joules. Now if you do both, what is happening? 0 plus 20, which is equals to 20 joules. So now from this, can I conclude? Everybody need to write example, freely falling case example. This all the points neatly how to write it. So please write it. Now you can see from here I can make one formula. That is what? Potential energy mgh plus half mv square, which is equals to what? Constant. That is only we can call it as what? Mechanical energy. Yes or no? Here also mg plus half mv square, which is equals to what? Constant. Understand? So like every case, if we'll sum this mgh plus half mv square, which is equals to what, guys? Which is equals to constant. So this is only what is the name of this one called as, Shruti? What is that called as? Law of conservation of energy. Understand? So energy neither be created nor be destroyed. Only it will be transferred from one form to another form. Is it okay, guys? Is it okay, everybody? Please respond. That is what is called as conservation of energy. So please all of you note it down. This is a very important one. So everywhere if you sum it, total energy remains constant, so that we is to get law of conservation of energy is true. So any doubt anybody you can ask me. So if we'll make it, then we'll go to the law of conservation of energy with the help of simple pendulum. You finish this, then I will go to that. Is it okay, guys? Have you understand really? Please respond me, everybody. So now, now let us go to the simple pendulum. Please write it this. Once it is completed, everything you should write it. All the 5 cases, A, B, C, D, E. Okay, that is everything. Tarun, have you understand, Tarun? Tamil Selvan? Law of conservation of energy, because exam it will come definitely, because it is very important question. Prove the law of conservation of energy with the help of one example. You have to explain briefly and you have to make it. That is it. Once it is completed, tell me. Adarsan, Maitreyan also. That is. So now let us go to the next one. Finished it, guys?
Yes, sir. Completed,
One
sir.
second.
Yeah, okay. Next, those who completed, you can keep heading. Conservation of energy in a simple pendulum. Conservation of energy in a simple pendulum. I will teach you more real things also. You can take. Like yesterday, I told you one example. I will remember if you'll go to the park. What is that, Mukil? I forgot the name. Columbus. Yes? Columbus, what we used to call, guys? I told you what is the name of the Columbus we used to call? Pirate ship. Understand? So fun fair ride, that is what we used to call as pirate ship. The simple pendulum is similar to the pirate ship. Is it yes or no, guys? Simple pendulum is similar to the pirate ship. Yes or no? It will go to and fro motion. Yes. So the to and fro motion only what we used to call oscillation. What we used to call? To and fro motion called as oscillation. Now you might be having or somebody of your home you might be having. Do you have a pendulum clock? Pendulum clock. Every 1 hour, tong tang, 1 hour clock, tong tang, 2 p.m. like that it will say. Down it will, you can see that one kind of like a spoon-like thing it is used to oscillate. Tang 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 tang. It is used to oscillate. Tuck 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 tuck. Have you noticed it? Pendulum clock, Ra?
Yes, sir.
Yes, you don't have people?
Yes, sir.
Yes?
No.
Those
Yes, sir.
So that pendulum is always will make oscillations. That is what we learned. Is it yes, guys? Pendulum is always will make oscillations. That is what? To and fro motion, coming back and going forward, coming back and going forward. So that is what it is used to do. So that is only we used to call it as pendulum clock. So now let us see in this how the energy will make the law of conservation of energy is true. So please all of you keep heading. Swinging simple pendulum is also example of conservation of energy, we can say. So right, conservation of energy in a simple pendulum. Everybody write it. Conservation of energy in a simple pendulum. Conservation of energy in a simple pendulum. Conservation of energy in a simple pendulum. Shall we start? Now,
Yes, sir.
Yes, sir.
all of you take this and all of you observe this one. Now, this is what we used to say simple pendulum. You might be noticed it in our lab, or else if you'll take in our home also you can make it, and the next offline class also we can see. So this is what we used to call it as, what we used to call this one, guys? Simple pendulum. Now, if you'll notice it here, this is a simple pendulum which we can make with the help of just one thread and one rigid support. So you can notice it, this is what we used to call it as thread, 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 and this is the simple pendulum. So now if you'll notice it here, so we want some rigid support and you have to hang the bob with the help of like this. So I will take one rigid support and I will take some thread and down I will hang, and I will hang some bob. That is what it is, a simple pendulum we can say. So now if you'll notice it, guys, here, this is what we can make it now. So when it is in this position, yesterday also I told you, this is what we used to call it as mean position. What is mean position? Understand? When it is in state of rest, so the energy possessed by it is equals to what? 0 joules.
0 joules.
Now, you can take, for example, you can bring it to this side or this side, any extreme. You can stretch this, you take this thread upside and you can keep the bob here. This is what? Now, what is the position of the bob? Let me imagine this is the position of the bob, A, or else this side. Now, from this position, you people will release. What is happening, guys? Like our swing. So it will go like a, what is that? Okay, I forget the name it is again. Columbus. So it will go forward, it will go again, go backwards, again go forward, again go backward. This is only we used to call it as oscillation. Yes or no?
Yes, sir.
Yes, sir.
Now, when the body is in motion, you can see when the body is in motion. So we are having here totally 3 positions. So this is state of rest. State of rest I am not talking. So when the body is in motion, you can see here. So the center position, that is what we used to call it as mean position. They are assuming as a. And this side, extremely high. Height, if you go height from the ground, this is what we used to call it as extreme position B. And this side also height it will come. That is also extreme position we used to call it as, what is that position, Ra? They're taking as
C.
Okay, guys. Now, let us draw a straight line passing through the center point. You can see this is what the basement of the ground. Is it yes or no, guys? Please respond. Now,
Yes,
you can notice it at the extreme position C and as well as extreme position B. It is away from the ground or not? Yes or no?
Yes, sir.
yes, sir.
Away from the ground means in the sense of it is possessing what? Only it is possessing
Potential energy.
only at extreme position, only it is possessing which energy, guys? Yes,
Potential energy.
potential energy. At B point also extreme position, which energy? Potential energy.
Potential energy.
So at this case, kinetic energy is equals to what? At this case, kinetic energy is equals to 0 joules.
0 joules.
In this case, kinetic energy is equals to 0 joules. Now, when it is in exactly mean position or center position, only which energy is present, Maunesh? Only
Kinetic energy.
is present. So at this case, what is happening? Potential energy will become 0 joules. Understand, Jayvarshini? So when the ball is in oscillation, when it is extreme position C, let me imagine. So here it is possessing potential energy like a free fall. When it is coming to the center, then potential energy is converting into which energy, guys? Potential energy is converting into kinetic energy. And understand everybody? So that
Kinetic energy.
maximum potential energy is converting into kinetic energy. So when the bob is coming to the middle center, it is only possess which energy, Ra? Only it will possess kinetic energy. Understanding? So once again it is started moving up. It is moving up this side. Means a ball is thrown upwards. Like so, kinetic energy is converting into which energy? Maximum
Potential energy.
potential energy. But on the process, slowly it is converting. Slowly the kinetic energy is converting into potential energy. So once the ball reaches to the extreme position, then which energy it will be having? Tamil Selvan? Once the ball
Potential energy.
Only potential energy.
only potential energy, the kinetic energy will become zero. Understand, girls? Alana, Laksha? So now, during the process A to B, which energy, guys? During the process A to B, which energy? A to B, conversion of both potential energy plus kinetic energy. Understanding? Now, same way, A to C also what energy, Pradosh? A to C. From A to C also, potential energy plus kinetic energy. You understanding? Now, at C point where? At C, only potential energy. At B also what? At B also only
Potential energy.
at point A only kinetic energy. But we do some here or some here and some this one and this one and this one remains always what? Remains
Constant.
Constant. This is what we used to call as law of conservation of energy. Purimara, please respond.
Yes, sir.
So now
Yes,
you
sir.
take values also. For example, at the extreme point, potential energy C is equals to, let me take 20 joules. Now, during the process from C to A, exactly at the middle. So what is that? P potential energy is equals to 10 joules. Kinetic energy is equals to 10 joules.
10 joules.
At point A to what is the kinetic energy? Kinetic energy is
20 joules.
20 joules.
20 joules.
Again, same way A to B at middle point, potential energy is equals to 10 joules.
10
Kinetic
joules.
energy is equals to 10 joules.
10
10
Sum
joules.
is what? Sum is equals to 20 joules only. When the ball is coming to the bob, B position, then kinetic energy is 0. Potential energy is equals to what?
20 joules.
Have you noticed it? So if you do the sum at any point, you can do at the point C sum at middle point of A to C, A to C to A, or at A, or middle point of A to B, or at point B. Everywhere the sum of the energy remains constant. This is what we used to call as, what we used to call, guys? What we used to call, Shruti? Law of conservation of energy. So please all of you draw this one and you can note it that this only black point, not what I explained. What I explained you have to also, you can note it down, but you have to draw this image alone neatly. Is it okay, guys? Everybody? That is what it is. The conservation of law of energy with the help of simple pendulum, you can explain this. Now, in exam, they will give you the numericals from this also. They will give you any energy at extreme point or mean point, and they will ask you to find the energies remaining point. So we can develop the numericals from this also. That is also we'll practice it. So this is the example which we can study the law of conservation of energy with the help of what, guys? With the help of what it is?
Simple pendulum.
Okay, so this is what this chapter, what is of work and energy. So work and energy with the law of conservation of energy, it is completed. So there is no kind of any other concept remaining. So mainly just finish it this. After that I will say meeting is going to end, you rejoin back and I will say. So this is only this about this chapter. This is only our syllabus also. Now we will solve one numerical and we will see, we can see what is the questions, how it will comes and all. We'll see now. So let us go with one question. So please rejoin in meeting after finishing this. We'll discuss few questions and we will wind up the session. So make it fast, everyone. So what is the heading you kept for this? What is the heading you kept? Conservation of energy with the help of Simple pendulum. That is what you have to write it. Simple pendulum. Conservation of energy in a simple pendulum. Jefferson, are you understand conservation of energy clear?
Yes, sir.
Anybody is having doubt, you can ask me. Hope you all understand what is conservation of energy. So power, conservation of energy, and as well as energy, and as well as types of energies, kinetic energy and potential energy derivations, and as well as